Hello everyone, thanks for joining me. Today we'll be talking about inductors. Before I get to that, I want to mention that I posted some exam problems on the exam page for exam 2. And just remember, it's important to recreate the exam environment at home. So as you work through those and the other examples, I hope you're able to do that. Now, last time we talked about capacitors and how we were able to use those to store electric fields, which is a force field, and that's why we can use it to store energy. Now, what about magnetic fields? Those are the other types of fields we can have in electromagnetic waves. Well, where do those show up in a circuit? We can see electric fields can extend in a capacitor between the plates. Say if we have, this is positively charged and this is negatively charged, we're going to get electric fields in between those two plates. So what about magnetic fields? And I guess I've been calling those B fields. So let's stick with B fields. Where would those show up in a circuit? Well, it turns out every time we have a wire with current flowing on it, there is a magnetic field around it by the right-hand rule. So even when we have just one long straight wire, like you can see here, this has inductance and it has a magnetic field around it. And it even stores some energy. It stores energy in that B field around the wire. But it's not a very strong B field. It's not a very efficient way of storing energy. And so a question arises is how can we change this geometry so that we can get maybe in a certain region of space, we can get a stronger B field. So what do you think? What can we do to change this wire geometry instead of having just one long straight wire? What could we do to that geometry to concentrate more B fields in one area?